Dear students, today I shall take the lecture of Mathematics 3rd, Civil Branch for Mathematics 3rd for BS 302. In this lecture, we shall cover up the topic of separation of variables for the partial differential equation. In this, we shall discuss separation of variable. That is important. We shall take the separation of variable with the help of partial differential equation. Partial differential equation, there are more than two variables are coming. That means del u over del x, del u over del y, del square u over del x square. These are the partial differential. In this module, we shall cover the application of partial differential equation consists of number 1, classification of linear partial differential equation of second order. That means del square u over del x square, that is second order. Del square u over del y square, second order. Del square u over del x del y, second order. Two variables. With the help of separation of variables. And we shall try to find out the solution of wave equation in one dimensional. That means we shall calculate the solution and with the examples of wave equation of one dimension. Let us take the equation of the second order is del square u over del x square plus del square u over del y square plus del square u over del x del y plus function of x, y, z, x, y, p, q, u is equal to 0. We shall take the calculator as the variable coefficient of del square u over del x square is taken as a, del square u over del y square is taken as c, del square u over del x del y we are taking the value of b, and we shall try to calculate b square is equal to 4ac. That means the coefficient of del square u over del x del y, the coefficient of del square u over del x square, del square u over del y square. Then we have to calculate b square minus 4ac. Imply b square minus 4ac. There are the three possibilities. If it may be equal to 0, it may be less than 0, it may be greater than 0. If b square minus 4ac equal to 0, then it is a parabolic classification. If b square minus 4ac less than 0, then elliptic classification 4ac. If greater than 0, then it is become hyperbolic. That means we have to calculate a, b and c. A is the coefficient of del square u over del x square, b is the coefficient of del square u over del x del y, and c is the del square u over del y square. And then we have to calculate the expression value of b square minus 4ac. If it is equal to 0, then it is become a parabolic. If less than 0, then it is become elliptic. If greater than 0, then it will be hyperbolic. Now let us take the example to continue of this. We are using the word del square u over del x, uxx. That means del square u over del x square. The coefficient is a, and here a is equal to 1. Del square u over uyy, that means del square u over del y square, and the coefficient is c. Here c is equal to y, and del square u over del x del y, a is equal to 1, c is equal to y, and del square u over del x del y, there is no coefficient, that is become b, and coefficient is 0. Now we shall take a is equal to 1, b is equal to 0, and c is equal to y. Then we have to calculate b square minus 4ac, and that is become 0 minus 4 into 1 into y, that is become minus 4y. If the y is less than 0, then it has become hyperbolic. because it is a negative. Parabolic if y is equal to 0. And if y is greater than 0, then it is become elliptic. Since b square minus 4ac equal to 0, then we have to take up the parabolic. If less than 0, then it is become elliptic. If b square minus 4ac greater than 0, then it is become hyperbolic. Here, if we are taking y is negative, then minus minus become positive and the function is become hyperbolic. Since b square minus 4ac is greater than 0. If y is equal to 0, then it is become b square minus 4ac equal to 0. B square minus 4ac equal to 0, that is become parabolic. If y is greater than 0, then it is become minus 4y less than 0, then the function is become elliptic. That is the classification. Now we shall take the method of separation of variable. Separation of variable, that means there occurs two type of the function, x and y, x or t. Now let us take the example of del square u over del x is equal to twice del u over del t plus u, and the value is given ux0 is equal to 6 e to the power minus 3x. That means u is the function of x and t. There are the two variables x and t. Now here t is equal to 0. At t is equal to 0, then ux0 is equal to 6 e to the power minus 3x. We have to calculate by the help of separation of variable. Solve this equation. Now let us take u is the function of x and t. U is equal to x is the function of small x and t is the function of small t. Now that is take u is the function of x and t is the function of t. If it is the trial solution, if it is the solution, if it is solution, then it must satisfy our differential equation. Then we have to substitute this value in this del square del over del x xt, u is xt, is equal to twice del over del t xt and u is equal to xt. Now we are separating the value of that is become t. We are taking the differential with respect to x, then t is become outside, that is become tx dash is equal to twice we are taking the differential of with respect to t, that is become x into t dash plus x into t. That means on this we have acquired this equation, tx dash is equal to 2xt dash plus xt. Now for the separation, dividing both side by xt, that is become tx dash upon xt, t is cancel out, that is become x dash upon x is equal to twice t dash upon t plus 1. Now this is the separated variables. There are the function x is separated, t is separated. That is become separation of two variables. Here x is one side, t is other side, and let us take we are equal to c. Now we shall solve x dash upon x is independent and t dash upon t is separately. Now let us take x dash upon x is equal to c, that is become x dash upon x, that means x dash upon x barabar c. A function having its differential upper side, that is become log x is equal to cx plus log x dash is equal to log cx plus log constant a, that is log x by a is equal to cx, that is become x is equal to a e to the power cx. इंटीग्रेट करने के बाद ये इक्वेशन आ गई, x is equal to a e to the power cx. Now x has been calculated. Now again another way we shall calculate t. t, that is become 2t dash upon t plus 1 is equal to c. Now c is taken as t dash upon t is equal to c minus 1 upon 2. T dash upon t is equal to c minus 1 upon 2. And that is become log t is equal to c minus 1 upon 2 into t plus log b constant. That is become log t is equal to b e की power c minus 1 upon 2 into t 1 by 2. That is become this. X has been calculated, t is also calculated. Now the solution is u is equal to x into t. Putting the value of x and t, the solution become u is equal to a e to the power cx, b e to the power 1 by 2 c minus 1 into t. Now a and b are both constants. That is become u is equal to ab plus e की power cx plus 1 by 2 e की power 1 by 2 c minus 1 into t. That is calculated. ab is equal to. Now we shall take the initial condition or boundary condition, that is ux0 is equal to a at t is equal to 0. T is equal to 0. We are taking t is equal to 0, that is ux0. And ux0 is equal to t is taken, this term is become 1. That is become ab e to the power cx. ab e to the power cx. And ux0 is equal to 6 e की power minus 3x. It is given. It is given by the initial problem. That is become on comparing, that is ab is equal to 6 and c is equal to minus 3. ab is equal to 6 and c is equal to minus 3. On putting the value of ab and c, the solution is become 6 e की power minus 3x plus 1 by 2 3 minus 1 into x. That is become c is equal to, putting the value of c, minus 3 minus 1 into t, and the solution will become 6 e to the power minus 3x minus 2t, which gives the required solution of the differential equation. Now let us take the vibrating sting. The sting is shown in the figure. That is OA is the x-axis. That is y-axis. Consider an elastic string tightly stretched between 2 points O and A. The sting is stretched between O and A. O be the origin and OA be the x-axis. Giving the small displacement on the sting, we are putting the sting in such way that P is any position of the displacement at any point, at any time, then one dimensional wave equation is given by del square y over del t square is equal to c square del square y over del x square for one dimension. For 2 dimension, it is become del square y over del y square. Now we shall take the example regarding this. A string is stretched and fastened at the 2 points L apart. The string is stretched O point and A point, that is L point apart. Motion is stretched from the displacing the string in the form y is equal to A sine pi x upon L. The displacement is the given from that which is released from t is equal to 0. Show that the displacement of any point at a distance x from one end at the time is given by this. We have to show yxt is equal to A sine pi x upon L cos pi ct upon L. Sorry. The vibration of the string is given by the one dimensional equation of the wave is del square y over del t square is equal to c square del square y over del x square. The string is stretched between O and A, that is at x is equal to 0, that is the initial condition y0 t is equal to 0, and ylt, that is at point x is equal to L, it is also stretched fixed ylt is equal to 0, and the initial velocity is 0, that means del y over del t at t is equal to 0, and at any point the equation is yx0 is equal to a sine pi x upon L. Using these conditions 1, 2, 3, 4, these conditions, we have to find the solution of this equation. Now, to solve the equation, there are the one dimensional wave equation having solution is given by y is equal to c1 cos px plus c2 sin px. This is the function expression of x, and c3 cos cpt plus c4 sin cpt. There are the four constants c1, c2, c3 and c4. Two constants from the x, two constants from the t. We shall calculate using these c1, c2, c3 and c4 with the initial and boundary conditions. First, we have the given, that is y0 t is equal to 0. On putting x is equal to 0 in this relation, cos 0 is 1 and sin 0 is 0. That is become c1 is equal to 0. Putting this value, we get c1 is equal to 0. Again, when y is equal to yx2 is equal to c2 sin px, c3 cos cpt plus c4 sin pt, since c1 is become 0. चार वेरिएबल है, चार वेरिएबल में से दो वेरिएबल, एक वेरिएबल 0 हो गया, तीन वेरिएबल रह गए, तीन कांस्टेंट्स रह गए, c1, c4, c3, c4 and c2. c1 is become 0. Now we are using the another initial condition del y over del t, that means differentiating with respect to t, and that has become c2 sin px and c3 cos cpt differentiating minus sin cpt into cp plus c4 cp cos cpt into cp, the coefficient of t, and on putting t is equal to 0, sin expression is become 0 and cos expression c4 is equal to 0. That means there are become four constants c1, c2, c3, c4. c1 is already 0 and c4 is equal to 0. There is remain only two constants c2 and c3. Now the solution is remain yxt is equal to c2 sin c3 sin px cos cpt. Now at x is equal to L, that is become c2 c3 sin px sin cos cpt, and y0t ylt is equal to 0. ylt is equal to 0, that means x is equal to L, that is become c2 c3 sin pl cos cpt, and y0t is equal to 0. This expression is not equal to 0, goes into the 0, and p is equal to n pi upon L. Sin pl is equal to sin n pi, that is p is equal to n pi upon L. On putting this value of p in this expression, yxt is equal to c2 c3 sin n pi x upon L cos n pi ct upon L, and imposing this vector yx0, putting this value at t is equal to 0, yx0 is equal to c2 c3 sin n pi x upon L, and cos t is equal to 0, cos 0 is 1, that is become c2 sin 3, and this yx0 is given as a sin pi x upon L is equal to, that is C2 C3 is become a naya constant A, and comparing n is equal to 1, and we get the solution of yxt is equal to sin pi x upon L cos pi ct upon L. That is the expression for value of this. Now let us take another example in the stretched string. The string is stretched in the form of y is equal to k Lx minus x square, which is released at the time t is equal to 0. Find the displacement at any time, at any point of the string at a distance x from one end at the time t. The vibrating string having the equation del square y over del t square is equal to c square del square y over del x square, with the initial and boundary conditions are y0 t is equal to 0, ylt is equal to 0, del y over del t is equal to 0, initial velocity is 0, and yx0 is given as k Lx minus x square. चार कंडीशन 1 2 3 और 4 कंडीशन है, 4 कांस्टेंट हैं, उनको निकालने के लिए therefore the solution is given as y is equal to c1 cos px plus c2 sin px, c3 cos cpt plus c4 sin cpt. Now putting the value in the first expression at x is equal to 0, in the first example we are taking that c1 is become 0. Again y del y, that equation remains c2 sin px, c3 cos cpt plus c4 sin cpt. Now we shall take del y over del t. Del y over del t means differentiate with respect to t. That has become c2 sin px, and that has become minus c3 cos ka sin cpt into cp plus c4 sin cpt into cpt. On putting del y over del t, this expression is become 0. c4 is equal to 0. First c1 is equal to 0, again c4 is equal to 0, and there is remain only two constants c3 and c2, and the solution is remained only y is equal to c2 c3 sin px cos cpt. Now we shall take the another ylt is equal to 0. Ylt means x is equal to L, and putting the x is equal to L, c2 c3 sin pl cos cpt is equal to 0. Here sin pl is equal to 0, and sin pl is equal to sin n pi, and p is equal to n pi upon L. Putting this value, then we get the equation c2 c3 is another constant bn. Why we are taking this constant? Because the term of sine is coming here, and sine coefficient is denoted by in the Fourier half range sine series, that is become bn. That is y is equal to bn sin n pi x upon L cos n pi ct upon L. And putting this value for general value solution, n is equal to 1 to infinity, yxt is equal to bn sin n pi x upon L cos n pi c upon L into t. Putting at t is equal to 0, we get yx0 is equal to cos 0 is become 1, and yx0 is equal to summation bn sin n pi x upon L, and yx0 is given as Lx minus x square is equal to this, and we shall calculate bn with the half range sine series. Half range sine series, bn is equal to क्या होता है 1 upon L by 2 0 to L fx sin n pi x upon L into dx, and you are seeing that is become 2 by L 0 to L fx sin n pi x upon L. Here function is given as Lx minus x square sin n pi x upon L into dx. Here we shall take integration by parts. That means 2 by L is outside, and Lx minus 1 x square first function, integral of this minus का cos n pi x upon L and divided by L upon n pi upon L, and that is become L upon n pi. Again minus, that is become L minus 2x sin n pi x upon L and L upon n pi का whole square. Again L का 0 minus 2x का minus 2 और sin n pi का n pi x upon L, L cube upon n cube pi cube 0 to L. And seeing this very constant sin n pi x, x की जगह L रखेंगे, साइन एन पाई 0, साइन 0 0, ये टर्म बेकार, इससे कोई वैल्यू नहीं मिलेगी. This value does not give any value. Here put x is equal to L, that is comes L square minus L square, ये कोई वैल्यू नहीं दे पाएगा. 0 रखने पर भी कोई वैल्यू नहीं, यानी कि 3 टर्म्स में से only 1 term will give the value. And when with putting this value minus का 4 by L, and that is become minus into this minus 1 की power n plus 1 L cube upon n cube pi cube plus या cos n pi, putting this value cos n pi minus cos 0 1. And when n is odd, that is become minus 2. So minus 2 into minus 4, that is become 8L cube upon n cube pi cube when n is odd. Otherwise 0 when n is even. Since cos n pi is equal to क्या होता है minus 1 की power n. इसलिए putting this value we get the value of n is odd, that gives the value 8L square upon n cube pi cube. When n is even, value is 0. That is become y xt is equal to sin n pi x upon L cos n pi upon t. And putting this value, we have substitute the solution of the equation, and that's all the complete of one-dimensional wave equation and separation of variable. Thank you to all of you. Thank you.